Hello there. My name is John Storey, and I'm the CTO of Datapath Limited. Datapath is a quite recent adopting member of the SDVoE Alliance, but we've been keeping a very watchful eye on all the activities because we're really sort of keen on your ideas of quality and latency. But it's really only just with the advancement of the AVP 2000 that we really feel that we can do justice to SDVoE in the markets and environments that we're in. And I want to take a few minutes really today to explain how SDVoE touches the sorts of markets and the sorts of things that we are involved in at Datapath. So always good to start with a slide from the SDVoE Alliance itself, so I can't be accused of there being any factual errors on this slide at all. So this is the classic view of SDVoE as presented as a matrix switching solution. So what you have a number of sources that are playing out through what are marked down as TX boxes, through a standard networking infrastructure to a number of receiver boxes. And such an illustration's been carefully crafted to hone the message. For example, you'll see there's more receivers than there are transmitters. That's the multicast capability being sort of demonstrated. And in these sorts of applications, the screens themselves, each output is shown as a screen. But and that's where screens can be large, people can be very close to them. So quality is really important in those sorts of applications. However, that's not really the use case that we see SDVoE in our markets, and I would sort of change that to really, in the majority of cases, that right-hand side of the screen is of the illustration, not so much the box going into a screen or screens, but going into some sort of processing PC. And what sort of applications might that be? So obviously for Datapath, our core business is in command and control, so wall controllers, and all the sort of infrastructure in that sort of environment. So that a wall controller at its heart is a PC box, and you need to ingest video into that as part of the role in command and control is to bring video streams in and present them on a canvas so that you can make those sort of decisions in the room. That illustration really doesn't serve that application justice because typically you would have very many inputs into that box. That's the whole point of a wall controller. So you'd have, if you like, many RX feeds into that. But again, wall control, the sources, rather than sports football, they're likely to be quite high quality, text dense, graphical. So the quality at which they are sort of shown is really important. Another application there might be media server. Now in this case, yes, possibly it is just one input, and maybe even just one source. And in that sort of market, you're using the SDVoE as a sort of high quality extended technology. But with media server, as well as the quality angle, they are critically dependent on very, very low latency operation. So having a way to do that with low latency, and you've got the low latency aspects of the SDVoE that's feeding that. So that's all looking good. Medical, again, a market sector that is critically concerned about the quality of the image. But as well as that, in many medical applications, there is actually real-time analysis of that information going on. So there's also the requirement for minimum latency. So these are sort of the applications that we come across in our market segments. And I'll just zoom into one a bit, because me drawing a box next to a bigger box, that doesn't really tell the story. Clearly, there is video capture going on here, and that's the critical part. That's really what Datapath offer across the board for their wall controller technology, and those video capture cards are part of what we offer to the wider market. Now, notice I'm going to be calling it throughout this a video capture card, not a frame grabber, because we're not all about grabbing a single frame. We're about the whole sequence, and it's about having all of the capabilities to do that. So the first one is you need to have the bandwidth, because if we are going to do justice to the quality of an SDVoE feed, which is capable of UHD, 444, so there's no sort of at the sort of video presentation layer, no lot of information. So you've got to be able to maintain that bandwidth. And as part of that capture, you clearly have to be able to do that with a low latency, to not throw away all the gains that customers have spent on putting a low latency interconnect in the first place. So if I focus on the first of those, the bandwidth question, I'll just give you some examples, and this sort of tends to inform how the design of these capture cards is done. Okay, UHD or 4K at 60 Hertz, that is pretty much on the nose of 500 megapixels per second, has to be delivered into the PC environment. Now, typically a PC wants that buffer as a 32, each pixel is a 32-bit word. Even if it's maybe 24-bit video, they want it as a 32-bit word, because that means that the PC operating hardware can get much more efficient access. So you're multiplying that megapixels by 4. So every stream is a 2 gigabytes per second stream of data that has to be sustained into that. I've shown this. This is a typical Datapath graphics card, and with everything we do, we're about not one channel but many channels. So again, to do justice to this, we're talking at least 2 channels. So you've got 4 coming in. So that's going to require a correspondingly high performance PCI Express interface to take that data out. And we supply all of our Vision SC range of cards with a 8-lane Gen 3 interface, which is capable of saturating above 6 gigabytes per second. So plenty of room for those 2 channels in their full glory, but also potentially scaled down, because all our capture cards have got multi-client, so you can have multiple copies of every capture. So plenty of bandwidth is sort of the first thing you've got to sort of make sure that there is. Secondly, we're talking about latency, and there are many arm-waving sort of explanations of how latency stacks up during a capture into a PC. But clearly, when we are supporting our customers, such as media server customers, they are very keen on getting the information into the graphics card for processing in the most efficient fashion. So we support GPU Direct and Direct GMA. Both of them have the word direct, which is the clue, and they are the direct-to-frame buffer technologies from NVIDIA and AMD. It's really important that that transfer is done as efficiently as possible, so that you can start processing the information as quickly as possible to, again, not throw away those latency gains that you've got from the interconnect. We also support something called live stream, which is really saying that we allow, in certain circumstances, the data to flow straight through to the user's buffer rather than putting it through our own frame buffer. It can only, obviously, that can only happen for the first sort of Premier client, but that can essentially mean that you don't have to wait for an entire frame to come through before you can start processing it. So you can save a frame in the sorts of applications that can start making worthwhile decisions on partial frames, which a lot of highly optimized applications can do. And I'm going to mention just audio and video synchronization. It's not about latency, but it's worth saying, because the signal is going to be bringing in audio embedded on that HDMI, that's valuable information, and that information needs to be kept absolutely in step with the video, and all of those need to be time-stamped at the same time. So I'm going to go back to the original slide about video capture. But really, there's something really wrong with this. It's missing the point completely. The point I want to sort of point out is that really we should be considering SDVoE as a new video standard. Rather than say we have a box and we only treat the HDMI, why wouldn't we consider the stream itself on the network as the signal? And therefore, you sort of cut out the middleman. You don't have the box there, and in fact, you are really then talking about network capture. So to redraw the initial sort of multiplexing, I would put it like that, where you can sustain very many inputs, and a connection from the switch or multiple connections from the switch can give you all of those into whatever PC processing environment that you're talking about. So you might argue that, well, if you're going straight from the network, why don't you just put it straight into a network card? Today's network cards, and particularly in Windows sort of PC environments, just cannot cope with that. The infrastructure is not in place. There is a lot of work in lots of quarters to make that happen. And you'll have noticed that NVIDIA have recently bought Mellanox for that very reason. But really, just putting it into a network card is not a solution here. It's also, it's a proprietary codec, so what would a network card do with it anyway? So I think the solution really is what we are presenting and launching at the show, which is the part of our Datapath Vision capture card range, which is the Vision SC S2, which is a dual-channel SDVoE capture card. Now, in the spirit of we want to just treat SDVoE as a sort of signal in itself, we have direct SFP plus ports into the card, and it's treated as just two receivers. So as far as an SDVoE network management point of view, nothing untoward is happening here. It just looks like you've got a very highly integrated dual receiver system. All of the comments about bandwidth, about latency, all have to be taken into account, and that is done in this design. So this is really just another of Datapath's range of capture cards, and I hope that that really tries to underline the fact that we now consider SDVoE as another video standard that we should therefore cope with seamlessly as we cope with HDMI, DisplayPort, SDI, and all the other standards out there. So really, just to summarize and bring it to a close, I hope that that has given you some idea why we have waited for a while, because a dual channel card like this was never possible until we got the ASIC in terms of the power and the sort of the design of that card. So we waited until we felt we could properly do justice to SDVoE, and hopefully you will agree that that has happened. So thank you very much. And I probably am a little bit ahead of time, so if anyone has got any questions, I'm very open to that. So has anybody got the first question? You're all very shy. Okay, I'll tell you what. There is a question that's come up, because as soon as you look at a picture like this, the question of connectivity comes up. So I've showed, oh, and by the way, when you buy this card from Datapath, we will throw in a PCI Express bracket for free. So apologies, it's not on the photograph. We support dual SFP plus cages, so that's very appropriate for easy fiber connectivity, which again, in the markets that we address, we feel is the sort of primary way that those signals will come through. But of course, the design and the power supplies has been ensured that you can just put in an RJ45 module, so you can take it in from a wired network if necessary. So hopefully that sort of answered the very first question that I tend to get asked about this. Okay, everyone. Thank you very much for your time. Have a great rest of the show. Thank you.